Trigonometry, Chapter 4, Graphs of the Circular Functions, Section 2, Translations of the Graphs of Sine and Cosine, Video 4, Putting It All Together, Period, Amplitude, Translations. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned vertical translations and combined them with horizontal translations. F of x equals d plus sine of x plus or minus c gives us, if d is greater than 0, the graph moves up d. If d is less than 0, the graph moves down the absolute value of d. If it is plus c in the parentheses, the graph moves to the left c units. And if it's minus c in the parentheses, it moves to the right c units. In this video, we put everything together. Changes in period and amplitude, followed by translations. In general, for a function of the form f of x equals d plus a times sine of b times the quantity x plus or minus c, double close parentheses, we will do the following. Number 1, sketch the graph of f of x equals a sine b of x, which captures the correct period and amplitude. In other words, we ignore the parts that are added or subtracted and only focus on the parts that are multiplied to capture the shape of the graph. And then second, we'll use translations to move that graph to obtain the graph of the original function. So after we establish the shape, then we use the d and the c, the numbers being added or subtracted, to move the graph around. Keep in mind, it doesn't mention it here, but if the a is negative, then that invokes a reflection across the x-axis. For example, let's sketch the graph of f of x equals 4 plus 2 times sine of pi times the quantity x minus 1. First, we sketch the graph of f of x equals 2 sine of pi x. So focus only on the numbers being multiplied. The amplitude is 2, and the period is 2 pi divided by pi, which is equal to 2. The quarter period is the period 2 divided by 4, which reduces to 1/2. So the quarter period behavior occurs at x equals 0, and then go up by halves. 1/2, 1, 3/2, 2/2. Remember, in the untranslated graph, before it moves, it always starts at x equals 0. Now for sine, the quarter period behavior is mid, high, mid, low, mid. And since the amplitude is 2, the high point goes up to y equals 2, the low point goes down to y equals -2, while the midline is still 0. Remember, the original graph has a midline of 0, and we haven't moved it up or down yet, nor have we moved it left or right. So let's sketch the graph of f of x equals 2 sine of pi x. The period is 2, so we're going from 0 to 2. Our quarter period is 1/2, so we cut it into 4 quarter periods. Remember, this is over 2, so from left to right, 0, 1/2, 1, 3/2, 2. Our amplitude is 2, so notice I put 2 horizontal lines, one at 2, one at -2, to remind me how high and low this is going to go. Our quarter period behavior was mid, high, mid, low, mid. So the quarter periods combined with the lines for the amplitude should tell me precisely where to put these points. 0, 0, 0.52 or 1/2, 2, 1, 0, 1.5, -2 or 3/2, -2, and 2, 0. Then we just sketch the graph. Now be careful, this isn't the final product. This is just the part of the graph that involves the multiplication, which establishes the period and the amplitude. Next, find the translations invoked by the original function. Well, the vertical shift is up 4. That's the number added in front. So we're going to move this graph up 4 spaces. 1, 2, 3, and 4. And notice I'm just keeping track of the quarter period points because those are the ones whose coordinates I'm going to keep up with to redraw the graph. And the horizontal shift is to the right 1. It's to the right because subtracting from the x moves it to the right. And of course, the 1 is a 1. So moving it to the right 1, we'll move it in 4 steps. 1, 2, 3, 4. And we've relocated the quarter period points from the original graph. And now we just have to sketch the graph by connecting them. Those points are the same. They just move from picture to picture. Now we could use the other technique where we identify the correct quarter period values and then substitute them into the new function to generate the 5 quarter period points up here. I personally recommend the graphing approach. Yes, you have to draw an intermediate graph, but trust me, every graph you draw helps you learn to do it better. Now you try. Pause the video and try the following. Describe the transformations of f of x equals 3 minus 2 sine of 2x plus pi, then sketch one cycle of the graph. I will warn you, I slipped 2 little differences in this one. You could probably pick up on them. You see what they are? All right. Here's a spoiler alert in case you have not paused the video yet. Solution in 3, 2, and 1. The 2 differences that I slipped into this one is, first off, there's a minus in front of the 2 in front of the amplitude number, which means that we're going to invoke a reflection across the x-axis. The period does end up being pi, quarter period of pi over 2, amplitude is 2. So here's the graph before it gets shifted. It's reflected, the period and the amplitude are changed. And then as far as the translations, it's up 3 and it's to the left pi over 2. Here's the other place where I snuck in a difference. In the problem before, there was parentheses so that we could explicitly see the number being added or subtracted to the 1, whereas here there's not parentheses. So in order to find the number being added or subtracted to the x, excuse me, we would have to factor a 2. Well, we don't have to factor it. You can do it without factoring, but factoring out the 2 from the parentheses inside the trig function shows that what's being added to the x is actually pi over 2, which is why it's to the left pi over 2. All right, I hope you caught those 2 differences. Okay, why is this not working? There we go.